Hello everyone, my name is Jayaditya. I am from ECEB. Today's topic about is vector random variables and vector joint distribution function. What is vector random variables and what is vector joint distribution function? We can see about in further slides. What is a vector random variable? A vector random variable is a collection of multiple random variables considered together as a single entity. It is that if you see, take an example. Some of the collection of all events in an in a set is called a variables and is called set of random variables. Rather than analysis outcomes one at a time, we can capture the a complete multiple dimension input simulations. Here we can see that mathematical notation x is equal to x1 comma x2 comma so on xn. Each xi is a random variable and a real world application. Heights, weights, measures and joints only of a single person's multi-dimensional outcomes, model complex phenomena and multiple multiplex dimensions, etc. Joint distribution function definition and meaning. Here we can see the joint distribution function of meaning and the definition. The joint cumulative distribution function CDF, joint distribution function is also called joint cumulative distribution function, qualifies the probability that all random variables simultaneously falls below a specific thresholds. It represents the complete probability behavior on the entire system. If you see that all the random variables are taken at a time and then it is called the into the system, then it is called the probable joint distribution function. Here two variable cases, f of x comma y is fxy is equal to x comma y is equal to p of x less than or equal to x comma y less than or equal to y. The probability that x does not exceed x and y does not exceed y simultaneously. The probability is that not exceed in small x and also does not exceed s small y simultaneously. General formula is f fx is equal to x1 comma x2 comma so on xn is equal to p of capital X1 is less than or equal to small x1 so on capital Xn is less than or equal to small xn, extending to all numbers of random variables. Joint probability masses and density functions. In here we can see the discrete case and the continuous case. First we can see discrete case. Discrete case, joint PMF. Joint PMF. P of x comma y is equal to P of capital X is equal to small x comma capital Y equal to small y. All probabilities sum equal to 1. If you see x1, x2, x3, so on xn, the probabilities of all x values become 1. Example, two dice are rolled. Each outcome pair has probability 1 by 36. Next, continuous case. Joint PDF f of x comma y integrable to 1 integral double integral f of x comma y dx dy is equal to 1. Here you see the area is equals to 1. Describe the probability density over a continuous region. Properties of joint distribution function. Here you see the properties of joint distribution function. Understanding these fundamental properties is crucial for working with multivariate distributions and ensuring mathematical consistency. By learning these properties, we can easily solve all the problems or estimate the probability of joint distribution function. First, non-decreasing property. If f is increased or stay constant as each argument is increased. Whenever f is increased, then other elements will also other variables also increase randomly. Boundary conditions, when f infinity comma infinity equal to 1 and f of minus infinity comma y equal to f of x comma minus infinity equal to 0, when both to the x and y are becomes infinity, then only we will get output as 1. When any one of the x and y becomes value, then it will gives the output as 0. Next, probability extension can recover marginal density by taking limits. By this, we can use the marginal and marginal distribution function by the taking the limits. Next, marginal distribution function extracting individual behaviors. Marginal distribution allows us to understand the behavior of individual random variables by removing the influence of others. They represent the signature of a single variable within the large multi-variable system. Here we can see that the marginal distribution function is used for single elements. If you see here, discrete variable and continuous variable are two types. Now first of all, discrete variable, marginal PMF of x, p of px of x is equal to summation of y into p of xy, is sum of joint probabilities overall y values. Next, continuous variable, marginal PDF of x, f of x equal to integration of f of x comma y dy, integrate joint density overall y values. Conditional distribution and density function. Conditional distribution reveals how one variable behaves when another is fixed to a specific value. Here, conditional distribution function is that when two events are present, first event and second event. The second event is depend on the first event. Then it is called the conditional probability. And the conditional probability is on the distribution and density function. Then those functions are called the conditional distribution functions and conditional density function. They are essential for understanding dependence relationships and updating beliefs lives like based on new information, etc. In his discrete case, p of x by y is equal to p of x comma y by p of y. Here y is already happened and x is happening based on the y. Probability of x gives y is equal to y, a condition on y being observed. Continuous case, f of x by y is equal to f of x comma y by f of y of y. Conditional density updating the observed values. It gives the further values updating to the system. Next, key insight reveal the independence. Independent variables happen p of x by y equal to p of x of x. When the x and y both are independent, then they have don't dependent on each other. If you see that updating the observation value, it is used for solar panel measuring the solar energy G to giving the house how much amount of rate giving the house day by day by calculating 1 month or 2 month entities. A example, campus job selections. Two juniors and three seniors applied for two positions selected randomly. The example illustrates joint marginal and conditional distribution is a concern settings. Possible outcomes are 0 juniors, 2 seniors, 1 junior, 1 senior, 2 juniors, 0 seniors. Joint probabilities are P of 0, comma 2 is equal to 3 by 10, P of 1, comma 1 is equal to 6 by 10, P of 2, comma 0 is equal to 1 by 10. Marginal, marginals are juniors, P of x equal to 0, 3 by 10, P of x equal to 1, 6 by 10, P of x equal to 2, 1 by 10. For seniors, P of y equal to 2, 3 by 10, P of y equal to 1, 6 by 10, P of y equal to 0, 1 by 10. Visualizing joint and marginal distributions. Visualizing represents transfer abstraction probability concepts into the integrative insights. This displays reveal relationships, dependence, and distribution and shapes that guides the statistical inference. Summary. Why these concepts matters. In summary, we can learn about all about the further slides. It's master Mastery of Mastery of vector random variables, joint distribution function and their properties forms the mathematical foundations for modern statistics and data science applications, etc. Model complexity. Vector random variable captures multi-dimension phenomena accurate. In here, we see that vector random variables will capture the multiple dimensions like 3D dimensions, 2D dimensions, and accurately and very currently. Next, probabilistic relationship. Joint distribution reveals complete interdependency among variables. Focused analysis, marginal and conditional distribution enhance investigation of specific aspects. Real world application essential for multivariable statistics, machine learning, and data science. If you see, marginal and conditional distribution functions are used for investigation and specific accept. These two are used when we take a event, then you find the event and the probability. These both are used for are knowing the event outcomes very depthly, and real world applications are we can use this are machine learning applications, data science, etc. Thank you.